Okay, folks, so here's some notes on how to find area between curves. And I wanted to start off notes by reviewing an old problem, which is just area under one curve. Because if you're good at this, it's not going to be hard for you to be good at the other one. So if I looked at this, oops. If I looked at this problem and I wanted the area under the curve under this curve from 3 to 8. And if I graphed the curve, visually I would be talking about this area here, right? And we already should know how to do this. You just do your integral trick. Remember, I put braces or brackets. I put from 3 to 8, and I do the antiderivative, which is raise to the power up 1, divide by the new exponent. Same with this guy. Raise the power up 1, divide by the new exponent, and raise the power up 1, divide by 1. Okay, and then you split it into, you plug in an 8 everywhere, and I recommend parentheses, even though this problem it wouldn't bite you, but if you ever get a negative it would. So you'll do it once with the 8 plugged in, a minus is necessary, and then once with a 3 plugged in. Make sure you put parentheses around this and, do it a little at a time. If you try to do too much, you will probably type it in wrong. So take however many steps it takes you. If you type all this stuff in, you get 122.6 repeating. If you type all this stuff in, you get 13.5. And if you do your subtraction, you get 109.16 repeating. So that's the area under the curve. That's one curve. So now we're going to take it up a notch. Although it seems hard at first, but it's actually really easy. I'm going to draw a picture of it for you. So let me pause this for. Okay, so today we want to, if I wanted to find the area trapped between these two curves, it's very similar to what we had before. Basically, I want the area in here that kind of looks like a smiley face. Now to show you how we're going to do that, remember, if I just do the normal integral of this straight line, it'll find the area all the way down to here, right? If I find the area of under the curve, it'll find this, right? So to find the area of this smiley face, you really just have to take the yellow area, which is the area under this straight line, minus the purple area, which is the area under the curve. The only thing you have to do extra work for that's different than last time is you have to use your calculator to find intersection points. So you have to find where these two graphs cross, because if I call this point A and this point B, then here's what your integral looks like. Your integral goes from A to B. This is if I'm trying to find the area of that little smiley face trapped between the two curves. So the integral from A to B of, and then you just need to do the top, let's call this f of x, and call this guy g of x. You have to notice which one's on top, because it matters that you do the top function minus the bottom function. That's the top, and that's the bottom. That is how easy it is. It's really, the math part will look no different than this. You'll have whatever equation for that straight line minus whatever equation for the curve. As long as you find where it starts and where it ends, it takes care of itself. So let's do an example problem. Okay, so if my directions were find the area trapped between these two curves, first thing I'd want to do is get a picture. You have to have a picture for these problems. So I would graph them both on my calculator, hit zoom 6 because it's a pretty normal screen, and then I would get my equations, my graphs. Now I don't need perfect graphs, but I do need a good enough graph. I could actually graph this one because it starts up 5 and has this slope here. So there's your f of x, right? And then I want to draw a picture of the g of x that comes down. So it's I'm just getting a general picture. What I care about on this picture is that I can tell which graph is on top Not the best picture. But I'm going to find the area of this weird shape. It's kind of like an almond, right? Okay, so this guy's g of x, and the straight line's f of x. Oh, I'll reverse that. Gosh darn it. Yeah. So the curve is f of x. The straight line's g of x, because I looked at these equations. Okay, so if I want that area, I need to find out where my integral starts and stops. So it's going to start here. It's going to stop here. Okay, so you use your calculator. You go second, calc, intersect. And first curve, hit enter. Second curve, hit enter. You want to scroll over for your guess, so it's pretty close to where they cross. And they intersect at -2, 1. Now, I only care about the x part of that. So I care about the -2 there. And then I'll do it again. Second, calc, intersect. First curve, enter. Second curve, enter. And then scroll up so it's close to where they cross. And they intersect at 2, 9. I really only care about the 2 part of that. So when I do my integral, these are always x values. It starts at -2. It ends at 2. So all that has to go in here is top minus bottom. Okay, which one of these graphs would you call the top the whole time? Oh, crap. I ran out of room. Hold on. There we go. Never happened. Which one's on top the entire time? This guy. So I'm going to go 2x plus 5 minus the one that's on bottom the whole time, which is this guy. Right? That guy's the bottom, that guy's the top. So I'm going to make sure you use parentheses here. If you don't use parentheses, you're going to get a problem wrong eventually. Now, that looks ugly, but when you do a little distributing and combining like terms, this turns into just every problem you've done before. I'm going to have a 2x, a 5, a minus x squared, a minus 2x, and a minus 1. So I'm going to put it in order. Minus x squared, and then I have a regular 2x and minus 2x, so those cancel. And then I have a 5 minus 1, which is 4. So you do all that work, and it just turns out to be -x squared plus 4. That is not a hard problem to do, right? You've done problems way harder than that. So you just take its integral. So the hard part of these is the setup. You have to draw a picture. You have to notice where it starts and where it ends, but you make your calculator do the dirty work for that. And then you have to make sure that you do the function that's on top minus the function that's on bottom, and don't screw up your combining like terms. After that, it's easy. Like -x to the third over 3 plus 4x evaluated from -2 to 2. And now let's plug it in. You'll plug it in once with a 2. Make sure you use parentheses, or you will probably get this wrong. Minus okay, you got that, and you type them in, and you will eventually get, if you do it right, 10.6 repeating. You can check if your typing skills are good. This is -8/3 plus 8, and this is 8/3 minus 8. Okay, when the negative sign goes in. So that's a straightforward one, right? Now for the tricky part. Sometimes you have to watch out, because if I asked you which graph is on top, you'd have to say depends, because look at this. For this chunk, the curvy guy, or f of x, is on top. For this chunk, the straight line is on top, or g of x. So if you ever get a picture that switches which graph is on top and bottom, you still have to find the intersection points, right? But you have to split this into 2 integrals, because part 1, you'd have to say the integral from a to b, which one's on top is curvy guy, f of x minus g of x. That's top minus bottom, right? Plus a separate integral from b to c, because remember, the part plus the part equals the whole. And on this one, the straight line's on top, so here you'd have g of x minus f of x. Because now this guy's the top and this guy's the bottom. So be careful. This is why you have to look at pictures when you do these, because otherwise you could get it wrong. So now let's do an example that works like this. Okay, so this is one of those weird ones. So if I asked you to find the area trap between here, at first glance you might not know it's a weird one, which is why you look at the graph. So I knew how to graph this one, right? Start up and then use the slope, or just graph them both on your calculator, because you're going to need your calculator anyway to find it where they cross. So here they are. The blue line's my cubed, and the red line is my other one. So if I were going to draw this, I can find some points that it hits. Looks like it goes up here and then dips down below and then goes back up, right? I don't know if it hits right on those points, but we're going to find out. So we need to find this intersection, and this intersection, because we're looking for the trapped area. And if you look at it, for part of it, the curve is on top, and the other part, the straight line's on top. So let me pause as I find these three places by doing second calc intersect. Okay, I'm going to save some time though and do it on my own here. Okay, so I use my calculator, and remember, I only care about the x parts. I don't care what the y is. I care that that's a negative 2.12. So we break it into two parts. It's going to be an integral from negative 2.12 to 0 of something, and then it's going to be plus the integral from 0 to 2.12 of something dx. Okay, so on these, you just got to be careful that you notice which one's on top. So for the first part, the top is curvy guy. So that would be x cubed minus 4x plus 2 minus, and use parentheses or you will get this wrong. Okay, and then the second guy, you have the straight line on top, so that would be 1/2 x plus 2 is on top, minus the other guy, use parentheses, x cubed minus 4x plus 2. Okay, so now it's a bunch of distributing and stuff. I'm going to write it over here. Negative 2.12 to 0, and if I do the distributing and combine like terms, I'll have a positive x to the third. I'll have no x squareds, but if I have a negative 4x minus a half x, that'll be minus 4.5x, right? And then I'm going to have 2 minus 2, so that's nothing, right? So there's one of them. Okay, and then dx. You're going to add to that the other guy, which goes from 0 to 2.12, but I reversed them. So here I have a negative x to the third, and then I have a positive 1/2 minus negative, which means plus. So plus 4.5x. And here I have 2 minus 2 again, so they're gone. I don't know if they always turn out this way. Maybe they do, maybe they don't. But either way, now you just have two problems where you're going to take the integral from negative 2.12 to 0 and the integral from 0 to 2.12. Okay, and you'll do your tricks, and then you'll make sure you split this into something minus something, and then you'll split this one into something minus something, and you will finally add them all up. So give that a try. I'm going to pause it and put the answer up here in a second. Alright, so when I did this, I got one of them with minus negative 5.06 and the other with 5.06 minus 0, and it equals 10.12. Now, there is something, especially if you see this, if they are exactly symmetrical, you really could do the problem once and double your answer. Their exact replicas just reflect over the line. That doesn't often happen. A lot of times one of these little lumps will be bigger than the other, and you'll get two different answers instead of just doubling it. But anyway, hope that makes sense. It's not that hard. It's a lot of what you did before, but good luck on the worksheet.